In this set, there are 5 children, namely A to E, and their ages are 4, 5, 8, 10, and 6 years, not necessarily in the given order. Each child has a certain number of chocolates with him or her, and the number of chocolates with each child is a positive integer. After going through the additional information, it becomes clear there are two things. One is age, and second is the number of chocolates with the 5 children, and would be a bit easier for us to deal one thing at a time, like either age or the number of chocolates. But after going through all the 5 statements in additional information, it becomes obvious that we can find out the ages of, or all possible combination of ages for the 5 children, but that the same is not true for the number of chocolates. So let's try to find out the ages of 5 children. One more thing can also be noted from the given information is that it doesn't talk about what is the age of a particular person, but it talks about what are not the ages of some of the given 5 children. So let's start with first statement. Here it says the number of chocolates with the child whose age is 8 years is one third the sum of the number of chocolates with B and E. Also, the age of B or C is not 8 years. From here, it becomes obvious age of B is not 8 years, and same goes for C also. In the next line, the number of chocolates with child whose age is 10 years is equal to two-thirds of the absolute difference between the number of chocolates with D and E. Also, the age of D or E is not 10 years. From here, it can be concluded that the age of D and E is not 10 years. He is neither the youngest nor the eldest of all children. So from here we can deduce that age of E can neither be 4 or 10 years. The number of chocolates with E is equal to the sum of the number of chocolates with the children whose age are 4 years and 8 years. Also, E is not 4 years or 8 years old. So E cannot be 4 years as well as 8 years old. In the last statement, it is given that the number of chocolates with E is half the number of chocolates with child whose age is 6 years. From here, it can be inferred that the age of E is not 6 years. So it becomes clear from these 5 statements that age of E is 5 years. So on the basis of this, we can enumerate all the possible cases for the ages of 5 children. So let's tabulate this information. Here, write down ages 4 years, 5, 6, and 10. And in these columns, write children. we have already found that age of E is 5 years and age of A cannot be 4, 10 as well as 5 years. Same goes for B, C and D. Now from here it is clear that age of A can be either 6 years or 8 years. So consider first case when age of E is 6 years. When A is 6 year old, then B, C, D cannot be 6 year old. In that case, age of B can either be 4 years or 8 years. So consider first case when age of B is 4 years. And as we know that age of C cannot be 8 years, so his age has to be 10 years. From this, age of D comes out to be 8 years. This is the first case. Or as we earlier discussed, the age of B could be either 4 years or 10 years. So in that case, assume it to be 10 years. In that case, age of C will be 4 years and that of D would remain 8 years. Age of A can be 8 years also from this observation. So when age of A is 8 years, then explore the possibilities for the ages of other children. It is already known to us that E is 5 years old. Now, in that case, age of B could be anything out of 4, 6 and 10. So it's not wise to go with age of B. Instead of we can consider this thing, that is age of D in that case cannot be 5, 10 as well as 8. So his age could be either 4, either 4 year or 6 years. So consider when it is 4, D is 4 years old. In that case, B can be either 6 year or 10 years old. Consider first one when B is 6 year old, then C has to be 10 and vice versa. Now consider the cases when age of D is 6 year, when D is 6 year, then age of B could be either 4 years or 10 years. these are the 6 possible cases for the ages of 5 children. So by the time we have finalized one thing, that is ages of the 5 children. Now let's move to the second thing, that is their ages. Let A, B, C, D and E be the number of chocolates with A, B, C, D and E respectively. Now come to the first problem. If C is 6 years old and the absolute difference between the number of chocolates with D and E is 10 years, find the number of chocolates with A. Let's see in which case C is 6 years old. The age of C is 6 years in only one case, that is our this case in which age of C is 6 years. So now check the information related to the number of chocolates. The number of chocolates with the child whose age is 8 years, it means A is one third the sum of the number of chocolates with B and C. It is one third of the number of chocolates with B and C, which is B plus C. Now, in the next statement, the number of chocolates with the child whose age is 10 years. In this case, the age of D is 10 years. So, D is equal to 2/5 of the absolute difference between the number of chocolates with D and E. It is 2/5 of the absolute difference between the number of chocolates with D and E. Now, in next statement, there is nothing related to the number of chocolates with any of the given children. In next statement, the number of chocolates with E is equal to the sum of the number of chocolates with children whose ages are 4 and 8 years. So from this, E is equal to 4 and 8 years, D and A. D plus A is equal to E. In the last statement, it is given that the number of chocolates with E is half the number of chocolates with the child whose age is 6 years. In this case, C is 6 years old. So it is also equal to C by 2. And in first question, it is given that the absolute difference between the number of chocolates with D and E is 10 years, which means 2 by 5 into 10. In fact, this is not D but B. So from here, B comes out to be 4. And after solving the equation that we have found so far, we can get the value of a as 10, that we can do just by solving the equation. So let's come to the answer of first question. It is asking for the number of chocolates with a only. So it has to be option D, which is none of these, because other option does not have do not have 10. So D is a correct answer in this case. Now let's move to next question. Which of the following statement is necessarily false? The first statement is the absolute difference between ages of D and B is 6. Let's check whether it is possible or not. The absolute difference between ages of B and D in first case is 8 minus 4, which is 4 year. In second case, it is 2. In third case, it is again 2. In next case, it is 6. So the statement B cannot be false, as the absolute difference between ages of D and B can be 6 years. Now let's move to statement Q. The absolute difference between ages of E and B is 3 years. So check it for E and B. In first case, the absolute difference between ages of B and E is 1. In second case, it is 5. In third case, it is again 1. In fourth case, it is 5. In fifth case, it is again 1. In sixth case, it is again 5. So the absolute difference between ages of E and B can either be 1 or 5 but not 3. This implies statement Q is wrong. So it has to be part of our answer. Now move to next statement. It says the ratio of ages of C and E is 3:5. Let's check this thing also. The ratio of ages of C and E. In first case, this ratio is 6 is to 10. No, it's not 6 is to 10, but 10 is to 5. In next case, it is 4 is to 5. In next case, 5 is to 10. Next, 5 is to 6. Next, instead it should be 10 is to 5. It should be 6 is to 5. In next case, it is 10 is to 5 again. In the last case, it is 4 is to 5. From here, it becomes clear that the ratio of ages of C and E cannot be 3 is to 5. Hence, statement R is also false. From this, it can be concluded that option D has to be our answer, as this option contains statement Q and R. to next question. What can be the absolute difference between the ages of B and E? So let's check it. B and E in first case is 1 year. In second case it is 5 years. In third case again 1 year. In next case 5 years. Again one and then five. So the absolute difference between ages of B and either 1 or 5 years. So option C is the correct answer. Now let's move to the last question of this set. Which of the following can be the age of B? From the table it can be noted that age of B could be either 4 years or 6 years or 10 years. So let's see which one of them is present among the options. Only option A contains one of the values out of 4, 8, 4, 6 and 10. Hence it has to be the right answer. That's all for this set.